So please confirm. Can you see my screen, friends? Can you see my screen now? That's good. Brilliant. Okay, so we talked about a lot about threads. We talked about that the threads execute on the core. This is your entire machine, and then there can be other processes also. Actually, in real life, there will be other processes also running. They will also have threads, and the OS scheduler will schedule the threads of all the processes to execute on the available cores. Of course, they will all get lined up because there can be many threads and that want to get executed in the core, and more the number of threads wanting the cores to execute, your operating system will manage it. So now coming back here, you see what we do is that when we write our code, so one thing is for sure, friends, one thing is for sure. I want you to confirm to me that you have understood the fact that no piece of code in Java, for that matter, actually other programming platforms as well, but let's be specific to Java. There is no single line of code in Java that gets executed out of a thread. In short, what I'm trying to say is that everything that is executed in Java is executed in some or the other thread, either in the main thread or maybe the other threads that are created from the main thread and started. And JVM also has got its own internal threads. It does loads of things internally while the execution of your application is happening. So there are some internal threads also that are running, especially the garbage collection threads, right? We will talk about garbage collection later. But then you cannot imagine that a line of code is executed which is not in the thread. Impossible. It is there in some or the other thread for sure. Got that? So far so good. So while the code is executing in the thread, it may so happen that you end up creating objects of classes, right? You end up creating objects of some classes, and those objects are created where? They are created in Java Heap. We also did talk about the primitive types. Now let me give you an example of primitive types and what exactly I mean by primitive types. So you see this in Java. There are loads of data types available in Java. For example, I have int. I'll say I is equal to 2. I can have char c is equal to, in single quotes, okay, if I say, even if I say 2, it's a character, it will be considered as a char, not an integer. But let me say, for example, s, okay, that's the value of char c. Then I'll say, for example, I'll say byte, okay, b is equal to, I'll say maybe 12, and I'll say short, which is bigger than a byte. I'll say s is equal to, and I'll say some value, and then I'll say int I have already given over here, right? Int I have already mentioned here. So int is the data type. Then I have long. I'll say L is equal to some value, and then I also have something like float. Okay, these are the data types. Float, f is equal to, float is what? I will have a floating point. I will be able to specify a decimal point here, so that if I'm, so whenever you want to, you want to store anything which is in decimals, then in that case you have float. But if you want to store a real big value, then you also have something called double, which is again, it supports precision points. So I'll say d is equal to, I can very well have whatever value, and then I can have some value out here, and I'll say d for double. So double is bigger than a float, float is bigger than a long. Okay, float and long, the difference here is that you can have a floating point here, and you have got a long is bigger than an int is bigger than a short, and short is bigger than a byte, and char is a different data type altogether. These are all numeric types. All of these are numbers, numeric types. Whereas you also have something like Boolean. Okay, I'll say Boolean, I'll say done is equal to either true or false. Okay, I'll say training done, okay, is equal to true or false. I'll say initialize, I'll initialize it to false, not yet done. Okay, like this. So I've got Boolean, I've got char, I've got byte. Note one important point, and this must be like take it as a thumb rule in Java. Take it as a thumb rule. all that starts with lowercase, all the data types, primitive data types, or rather let me put it like this, all the data types in Java that starts with lowercase, these are all primitive types. All the following are primitive types. All the following are primitive types. Okay, these are all primitive types. Okay, that's okay. The spelling is wrong. That is the reason this is complaining. So primitive. This is the right spelling. Yeah. So primitive types. Correct. This is how it is. These are all primitive types, and it stores some value at any given point of time. So I don't remember. I don't need to remember, because all whenever I want to know what is the max value of long, I can always say long dot max value. This will give me the max value of long. If I want the max value of integer, I can always say integer dot max value of integer. And if I want to find what is the max value of byte, so I can always say byte dot max value. That will give me the the max value of the byte. So that's not a problem. You can always get what is the min and the max value of each one. It's char and boolean. There is no question of min and the max value. It's always a character. It's always a boolean value, either true or false. But these are all primitive types. And you see, what is one common thing among all of these primitive types, is that they start with a lowercase. B is lowercase, C is lowercase, and so on. But then you do have data types like these. Now all the following data types are actually wrapper classes. They are classes. So the value of these, when you create objects, so you wouldn't say these are primitive types. You will say these are objects, these are references, or these are objects. So I'll say Boolean, and I'll say training done object is equal to, or I'll just simply say training done, B, or okay, I'll say training done reference. Okay, let me use the term reference. Okay, I don't want to confuse you guys. I'll come to the reference later on. Training done Boolean. So now here also I can very well say false. That's fine. But if it was prior to 1.5, I had no choice but to say Boolean, and then in brackets I'll say false or true. But that is deprecated now. Why? Because you don't need to do it. It is, you can directly assign the values, and it does auto boxing. We will come to auto boxing later. Then similarly, you've got character, and I'll say character object. Okay, object is equal to, I can give some value here. Similarly, I can have all the number types also, everything that you have over here, number types, number types. And here I'll say byte with an uppercase, friends. Now is this a primitive type, or this is an object? This is an object. So I'll say byte object, or I'll say, okay, it's giving me a suggestion. I'll say a byte, which is absolutely okay, and then I give a value here. Okay, and then similarly I will have I do have a short, right? And then short, I'll say a short is equal to, and I'll say 45. And then similarly I will have integer, not int with I as an uppercase, but complete word integer, and I'll say a integer, right? An integer. Okay, now why it's not giving a integer is because it must be an integer, isn't it? This IDE is pretty smart. So you give some value here, and then similarly you have got long, right? A long is equal to some value, and then similarly, okay, here I will have to say L in order to represent that as a long, and then I have got float. Okay, and I'll say a float is equal to, and some value dot something, and I'll say F here. And then similarly I will say double. Now I'll say a double here is equal to some value, something like this, and I say D. Correct? So take a look at this. These are, these are classes. I mean, when I say classes, this is a class, this is an object of that class, this is a class, this is an object of a class of the class. These are all classes, my dear friends, and these are all the objects of those classes. Correct? And you can assign values. That's cool. Now, what is the difference? Once again, what is the difference? What is the difference? The difference here is that these are primitive types, whereas these are objects of their respective classes. Why do you need objects here? Why do you need wrapper classes? Why wouldn't you really just simply proceed further with primitive types? Because many data structures, I repeat, many data structures, right? Converting primitive data types, yes, Likita, you are right, Likita, here exactly. Auto boxing exactly means that it wraps up the primitive into wrapper classes. Well, Bhartiya, good point. Because Java is object oriented, so wrapper classes are needed. Well, it's a good try. It's a good point, good try, but that's not really the reason. But you are close. I won't, term it as a wrong statement. You have a point. I would say rather you have a point, but then there is a bigger reason. Yeah, into integer. Why? Why is integer needed when int is already there? And you know what? See, always, as I said, never shy away from getting into the source code. So when I say integer and int is equal to 4344, where is the value getting stored finally? Where is the value getting stored finally? When you will say it is stored in an integer. Okay, integer is a class, but in integer class there is something called value, which happens to be final. Can you see this? It is here in this final int value where the value, whatever value you assign, actually gets stored. Private final int value, it gets stored. And what is it? It's an int. So eventually the value is getting stored as an int. So why do you need an integer class? Why do you need an integer class? The reason is that, okay, what I'm going to do here is, let me bring this out from here. And I'm going to share all of these things with your friends. So don't worry, I'm going to share this. Okay, so here you go. So why do I need this? Why? The reason is that many a data structures, I repeat, many a data structures in Java, they are designed by Java to work on objects and not primitive types. For example, if I have to put all of these values, if I have to put a numeric value in a collection, when I say collection, like for example, if I say I need a collection, and or say let me use a list, I'll say list, and I have got a list of say integer. I cannot have a list of string. I can of course have a list of string. I cannot have a list of int. Correct? So integer, and I say I just simply say some values is equal to new array list. Correct? New array list. Now when I do this, I'll say values dot add, and you see what it takes as a parameter. Is it taking integer as a parameter or an int? It is taking integer as a parameter. It is taking integer as a parameter. So when I say here, I say integer, I'll say v1, that is the value 123. I can very well pass this v1 as a parameter here. So you see this gets added to this data structure. This is the data structure which internally maintains all the data in an array, and you can keep on adding multiple values to the collection. This is an array list kind of a collection, and we will discuss a lot about this when we reach to it. But then otherwise, try and understand here. You see it's not taking a it's an integer that it is taking as a parameter. It is still working. Why? Because it has automatically done the auto boxing, and that is the reason it is working. Okay, now let me make this as an int, and now it doesn't work. You can see this gives me a compilation error. Why? Because I cannot create a list of int. It must be a list of some or the other object type. It must be a list of integer, it can be a list of string, it can be a list of double, it can be a list of whatever I want, but then whatever I want must be an object. So you see this now, the moment I make it as an integer, well, this is good, no issues at all. You got that? And you would say that you said it is an integer, but then you are passing an int. Why? Because auto boxing is in play over here. It automatically boxes this into an integer. Automatically it does the job for you, so we don't need to worry about it. Right? But then otherwise, see, directly also I can very well say 23. Same stuff, this is auto boxed into an integer, object of an integer class. And then I can keep on adding other values. I can say 23, I can say 24, I can say 25. That's how it is. So not only list as a data structure, there are many such n number of data structures that are there in Java, and those data structures and the algorithms that those data structures work with, they work on objects. And that is the reason why you do need wrapper classes for these data types. Otherwise, how will you put the values in those data structures, which are very, very powerful data structures, and you will certainly need them in your application extensively. You will need these data structures, and you would want to execute the algorithms that they have built into these data structures. Any doubts, any questions? Well, I don't think so. Synchronization and multi-threading for that purpose. In fact, all of these data structures that we talked about, quite a few of them are thread safe and quite a few of them are not thread safe. And all of these data structures that I talked about over here, which are wrapper classes, they are all by themselves as such, by themselves, they are immutable. Please repeat. I used a term. What did I say? All of these data structures are immutable. Please repeat. What did I say? They are what? Immutable, cannot be changed. Yes, they cannot be changed. Very correct, right? Immutable. Superb. What does this mean? If I have an integer here, and if I say integer I is equal to, I say 25, I is equal to 26, I have changed. I say I, what will it print? What will it print? Tell me. Take a look and tell me, what will it print? Will it print 25 or 26? And I said integer is immutable. It cannot be changed. The value cannot be changed. But there is no compilation error. And when I run also, there won't be any error at all. And it will print which value? What value will it print? Exactly. It will print 26. It will exactly print 26 without any issues. See this. It will print 26. You see, here it is. But then you said, you may think that, Shakir, you just said that it is immutable, cannot be changed. I'll come to it. So there are some topics that needs to be discussed, and we will discuss them as we proceed further. So here I have to discuss a topic called immutable. Okay, that's what we're going to talk about as we proceed. So far so good. So this is needed. So that was the point that I was making. You do need you do need all of these data types. You need wrapper classes so that you create objects of those classes, and you can put them into data structures like these for the processing purpose, for your processing, for processing of data. Okay, now, so as I said, integer, when I say int I, okay, I is already defined. I'll say age is equal to 25. If this is what the variable is, int age is equal to 25, you see it is int. It is primitive type or an object? It is a primitive type. It is not an object. So this variable and the value of the variable will be there in the stack for the main thread in which the main function is getting executed. So main is my function, and you see this here itself. This is my main function. Within this main function itself, this age will be declared, and the value 25 will stay right here in the stack. I repeat, 25 will remain right here in the stack. So let me remove these three, or let me put this up here. And if this is my main function, right, in the main function, if you have written something like this, okay, if this is what you have written in the main function, and you write here int age is equal to 25. Okay, now for the sake of clarity, I will just increase the width of this so that it becomes easier for me to explain. It becomes easier for you to read. Okay, that's how it is. Okay, here it is. I'll remove this F3 and F4. We have done the discussion with respect to that. We are in the main function, and main function executes in this thread. So int age is equal to 25. So where is age? Where is age? Let me make this as age 1. Where is age 1? It is there in the stack. It is here in this local function, and age 1 is a local variable. How would I make a statement about age? Age is what variable, friends? What did I say? It's a local variable. Why am I saying it is a local variable? Because this is local to this function. All of these variables are local variables. Why? Because they are declared locally within this function, and these variables will not be visible out of this function. Simple. So this is a local variable. Int age is equal to 25. Now I'll say integer age. So this is age 1, suppose. And then I say age 2 is equal to whatever, maybe 35. This is age 2. Now, is this an int? No, this is an integer. Is this a primitive type? No, this is an object of class age2 is an object of class integer. Where is age2? Where is age2? Age2 is still right here. Age2 is still right here. So when I say integer age2 is equal to 35, where is age2? Age2 is still over here. So let me color this up here. Okay, I think I won't be able to color that up separately. No problem. So this is my main function. Okay, so let me do something like this. This is my main function. Okay, this is the main function. I understand this is post lunch session, and post lunch session is not so very easy to attend. I understand that, but see, pay attention. This is going to be, this will help you all a lot. So I said within the main function I'm writing int age1 is equal to 25. This is what I've written. Okay, this is one thing. So my age out here that I have written here is, this is that age1. This is the variable, but I'm saying this is primitive type because it is int. Now instead of int, I will say it's an integer, and I'll say this is age2. Right? When I do that, when I say this is age2 like this, and I say 25 or whatever the value is, I'll say 35 for example, whatever the value is, this age2 is not a primitive type. This is an object. This is an object of which class? This is an object of class integer. Age2 is an object of class integer. Where is 35? Okay, in my program, in my code is equal to, I said 35, but then this is an object. All the objects are created in Java Heap. I repeat, all the objects are created in Java Heap. So an object of class integer will be created out here in Java Heap. And this age, would refer to, this will refer to this object here like this. This will refer to this object. This age2 is a reference variable. I repeat, this age2 is a reference variable. I repeat, age2 is a reference variable which is pointing to this object. Whenever anything is written to memory, note my words, whenever anything is written to memory, that gets written to some of the other memory address, and the memory addresses are typically, it looks like this, typically, and they are long memory addresses, they are addresses. So this is the memory address where this object is created exactly, and this age2 is the reference variable pointing to this object, and actually the value 35 is not here in the stack at all. It is there in this object. Now tell me, what is the name of the data structure? What is the name of that final in which the value 35 will be stored? Tell me where it is stored. I go to the integer class. You remember I did show you something called what? Come on. Value. You remember this? It is this value in which the value will stay. So it is, value out here. So this is my value is equal to, this is exactly where the value will be. Value is equal to 35. So this is what kind of an object? This is an object of which class? Come on, tell me. This is an object of which class? This is an object of class integer. That's how it is. This is an object of class integer. That's how it is. So age2 is an object of class integer. The object gets created here, and the value is equal to 35 is here. While writing the code, you assign the value like this, but then actually internally, while managing memory, this is exactly what happens. Any questions? Any doubts? Any questions? Any doubts? So is the case with all the other objects of, I mean objects of all the other classes. For example, I may write here string name is equal to, I'll say PWC. Okay, this is the name of the company, suppose. So string name is equal to PWC. Where is name? Come on, tell me, where is name? Where do you think name is? So I have written here string name is equal to, I'll say PWC. So where do you think name is? My question is, where is name? Name is still where? Where is name? Tell me. Give me the answer. Where is name? No. I'm saying name, name, the variable. Where is main? Yes, it is in stack. You're right, Anand. Yeah, it is a reference variable, but where it is? Yes, Rakesh, you're right. Correct, Bhartiya, that is right. Correct, it's in stack. But now see my question. Very good, very good. Now my question is, so I asked you where is name, so you all said stack, just perfect. Now my question is, where is the string object actually created? Where is the string object? Name is a reference variable. It's a reference to an object of class string. Where will be the string object? Yes, exactly. Exactly. So you will have your string object created over here. Okay, so tell me, what is the data type of this object? This is an object of which class? Tell me. It's an object of class string at maybe some or the other memory address. And where is the value PWC? Tell me, friends, where is the value PWC? In the string class? Yeah, it is there in heap. Of course, needless to say, a string is an object in heap, so the value PWC is within that object, but then no, of course not stack. Name is a reference variable that points to an object. So name, this is the reference variable. This is pointing to this object string. See this. See this. So I have my name object pointing to string. Name object pointing to string. And PWC. Do you think PWC will be here within the string object? Okay. Within the string object. Now I'm going to take you to the source code. Okay. Like I had taken you to the source code of string of integer, I will take you to the source code of string, java.lang.string, and then here in java.lang.string again you see I have got something called value out here. Can you see this? Value. Now tell me where the value PWC is. Where is P? Where is W? Where is C? Where is P? Where is W? Where is C? Do you all know how to pop out the chat window here in Zoom in this Google Meet? Because if I have to see the chat, I have to come back to this entire presenting window, and then everything that is there behind doesn't. I mean, it covers that up. Is there some kind of a layout, captions, full screen, use photo, report, problem, change layout? And what kind of layout I must use in order to just get the chat window? I don't know. It doesn't seem to be right. I don't find an option here that helps me to pop out just the chat window. Nah, it doesn't help me. Meet and coffee attachments and stuff and all. Okay, no problem, can't help it. So we can't do this on Google Meet. Yeah, and yeah, that's really bad. Okay, anyways. So you see now, you tell me. You tell me now, where is that P, W, and C stored? Don't you think it is stored in the value? But what is that value data type? What is the data type of value? What is the data type of that value? Take a look at this byte. What is it? Is just a byte or a byte? No, is it just a byte? Take a look. There are square brackets there. Is it it's a byte array. Correct. Correct, exactly. It's an array. It's a byte array. It's a byte array. Now listen to this very carefully, friends. Again, $1,000,000 point. See, there are certain things, which are very, very critical and very important, and very, very important. One of those things is this: each and every array in Java, whether it is of primitive type or it is an array of a class. I repeat, this B is in lowercase, that means it is primitive type. So this is an array of primitive type. So whether you have an array of primitive type or you have an array of a class, whatever the case is, it's a thumb rule. Arrays are always objects. I repeat, arrays are always objects. I repeat once again, arrays, whether it is of type primitive or it is of type some class, arrays are always objects. So what happens here is this: it creates a byte array in memory, and here you have something called value, and that value is of type byte array, and it is this byte array that it refers to. It is this byte array. Further, there is nothing. This is an array, so it doesn't refer to anything else further. So this is exactly where you have P in the 0th element. This is exactly where you have W in the 2nd element. The first element actually, it starts with 0, 0, 1, 2 and so on, and in the 0, 1, 2 and the 3rd element it is C. Starting with 0th element, P, W, C. This is exactly where the values are. You got it? See the entire picture here. Take a look. It's so very simple. It is so very easy to understand. Here age 1, it does not have any object here because it is primitive type. The variable as well as the value of the variable both are here. Here in case of integer age 2 is no doubt in the stack, but the object is created here in heap, and this age 2 references this object. String name is equal to PWC. Again, name is an object of class string, so name will be the reference. So I actually wouldn't have, while writing the code I will be writing PWC here, no doubt about it. While writing the code, that's what I write, but actually this name will be what this entire thing is. This name is a reference to the string object out here, and then that string has got value internally. Value references the char array. This is a char array. This object is of type char array. Sorry, byte array. It's not a char array. It's a byte array. If they had kept it as a char array, it will not allow you to store in string some other type of characters which are non-English and non-ASCII. So it has a byte array. You see, value refers to this object, and this is exactly where the values are. Any doubts, any questions? Any doubts, any questions? Okay. Okay. Yeah. Tell me. No. Absolutely not. Annie, can you tell me what is the question? I am beginner in Java. No problem. But it's name, an object or a reference variable. One and the same thing. So when I say good question, why it's a silly question? It's not a silly question at all. So name is a variable of type string, and if it is of type string is a class. So you can very well say name is an object of class string, and at the same point of time, if it's an object of any class, string or any other class, it will hold what? Not the value, but the reference of the object that is created in heap. Hence, I can very well say name is an object, or I can say it's the object reference, or short form, just a reference. So when I say reference, I actually what I meant was object reference. That means name holds the reference of the object that is created created in heap. So the value of name, if you ask me actual value of name, the value will be sorry, name is here, right? This is name. So if suppose this is if this is the memory address where the name gets declared, maybe some, of course, that would be a different memory address. Okay, if this is the memory address where string got declared, right? If this is the memory address where string got declared, and let me put it nicely, and I'll say 12. This is the memory address. You know exactly what this name is a reference. Why do we call it a reference? Because this name will actually hold the value of this reference. Internally, what Java does is that when I want to print the value of name, so you see this, I have set string. Where's that? Data types. Okay, I said string name is equal to PWC, and now when I say s out, and when I say give me the value of name, you know what it prints? It's going to print PWC, isn't it? Right? It prints PWC. Why? Because internally Java is smart. It knows that I want the value of name, not the reference variable, but then otherwise actually internally this name refers to this object. That means it holds the value of this reference variable, and then when I want to print it, it goes to that, it goes to the value, from the value it gets to the byte array, and in the byte array it sees PWC, whatever the value is, it takes that value and it prints it. That's how it is. That's exactly how it is. If you still want, that a name dot hash code will not still give me. Right, no. So I do not have any function over here which will give me the exact memory address where it is. But then otherwise, you see, I'll show you. Let me create a class out here. I'll create a class of my own. I'll say class customer. Okay, and this is a simple class, not the class by Java. It's my own class that I have created. And when I say customer, C is equal to new customer, you see this, when I try to print the value of C, I'll write S out, and when I try to print the value of C, you know what will it do? It will actually print me the it will convert it to string, but that string will contain the memory address where it was actually declared runtime. So please see this. Okay, can you see this? At the rate 3CB5CDBA, what is this? This is the memory address where this customer object got created, and then it has prefixed the entire name of that entire the fully qualified name of the class, and the suffix is at the rate the memory address where it got created, and that is how it prints it. Now string is very smart. They have overridden the toString function. So if you go to the string class, you will see there is something called you can see this toString out here, and in toString it returns this, and there is a special implementation that is there in this of the string class that is given by Java, which actually prints the value of it instead of printing the memory address of it, but then otherwise it holds internally the memory address. I hope that answers the question. Right? Yeah, great. So references, when I say references, it's actually nothing but the object reference. It's nothing but the object itself. So okay, one can very well argue with me, right? Shakir, name is not an object, it is a reference variable. Object is this. Agreed. So if you want to be very specific about making your statements, if you want to be very, very peculiar about what you are putting in your statement, then yes, name is a reference variable pointing to the object which is there in memory. So name is a reference variable, and this is the object that it points to. Now is that clear? This is better. Name is a reference variable. We always, while writing code and while talking to our colleagues, we just go ahead, okay, so and so is the object that you need to declare. Now what we are essentially trying to say is that you create an object, you declare an object. Of course the object gets created in heap, and there is a reference variable pointing to that object, but the perfect and the dot perfect statement would be that name is the reference variable pointing to an object of class string in heap. Age 2 is a reference variable pointing to the object of class integer which is created in heap. Now is that this is clear now? I hope there is no confusion. and to every one of you all, not just simply Kaushal or Anikendu, but every one of you all. I hope this is clear. So whenever it's a class and you declare a object of that class is equal to something, then you say, okay, this is an object, but actually this is essentially if you want to be very peculiar about making a statement, you will say this is a reference variable pointing to an object that is created in heap. Similarly, so is the case here. I said customer is my class, and I say customer C is equal to new customer. So what will happen? You will have a, so here I'll just put this up here. Okay, so here you see I have another statement here, and what that statement looks like: customer C is equal to new customer. Correct? That's how it is. Customer C is equal to new customer. Now, where is C? C, and what is C? C is the reference variable. I repeat, C is a reference variable pointing to an object of which class? Oops. Tell me, pointing to an object of which class? Sorry. Customer C is equal to new. Okay, so you see this here, we have this object here. So this is an object of which class? Customer. This is an object of class customer, and C is a reference variable pointing to the object of class customer. It is pointing to an object of class customer. Here you go. See this? It's referencing. Any doubts, any questions? We will proceed further on the concept of these objects and stuff, friends. So please, you can absolutely feel free to ask questions. Yeah, any questions, any doubts, absolutely feel free. This is clear, friends? The concept of references. The concept. So why does string data is stored again separately on a byte array? That's how the design of your Java code and the Java library is. How will you store? See, I'll tell you, it's a good question actually, Abhijit. It's a very good question. Abhi aap log sab is baat ko samajh lo. You all understand Hindi? Is there anyone who doesn't understand Hindi? Don't worry, we will continue in English. So don't worry about that. But then I hope you all understand Hindi. Is there anyone out there who doesn't understand Hindi? Okay. So there are people from, other part of the country. No problem. Absolutely fine. Don't worry. We will not start in Hindi. Don't worry. Okay. So I wanted to start my camera, and it's out here. See, friends. Understand this. People with 5 years and 6 years and 7 years of experience also, they tend to kind of ignore this point, or they never ponder over it. Each and every piece of data that gets stored, whether it is a Java application or anything else, whether it's Java, .NET, PHP, TypeScript based, Node.js application, whatever that gets stored in memory is always of primitive type. Otherwise, all the other things are convenient classes. For convenience, they are convenience classes. They provide wrapper classes so that it becomes easier for you to execute simple algorithms on your data structures, on the data. If they do not provide you with these efficient classes, which are data structures, many classes are not data structures. They don't hold on to the value of anything. They just execute some behavior. There are some classes More often than not, yes, you have classes which hold some data, but eventually downstream they hold all the data in primitive types. So it's not possible even if the author of this Java wanted to. It is not possible for that author to store the data of P and W and then C in anything other than an array of character or array of byte. Byte is a primitive and char is also a primitive. Integer also. Integer, so to say, but this value is int. Right? So eventually all of these data structures which are classes, when you put data into them, they get finally stored in some or the other primitive type. There is no other way in computer technology otherwise. Why do they provide? So that's what C is a low-lying, low level programming language. Low level is not low level, in fact very powerful. Low level is that you can do low level programming, you can talk to the hardware. And there in C programming language, you do not have string. You do not have string, my dear friends. है ही नहीं आपके पास string. बहुत अच्छा question है ये. Thank you so much for asking this question. It's a post-lunch session, so I hope you are not sleeping. Can I get a quick roll call? Can I get a quick roll call? Bharatiya says present, so okay, that's nice. Okay, good, cool. So understand this point now. Shall I not show you a program, and how about seeing your program execution in memory? Let me do that. Yes, I have a tool called MAT, Memory Analyzer Tool. Okay, the name of the tool is Memory Analyzer Tool. Okay, what am I going to do now? I am going to do something here. See, something very interesting. I'll go back to my IntelliJ IDEA. Okay, and I will run the same program. That's fine. Or else, yeah, it's okay. I can run the same program. That's okay. And I will create a list of string. Okay, sorry. I'm creating a list of string, and I am creating values. Okay, values is equal to new, and I'll say array list. Okay, and I will say for int I is equal to 0 until I is less than, I'll say 1000 I plus plus. I'm running a loop. I'll say values dot, I'll say add. I need to add a string, and I will write something like this. I'll say random. Very simple stuff. Once you get hang of this, entire Java stuff by the end of this day, then the only thing that remains is actually knowing these classes, which is absolutely Pappu. Is equal to new. Pappu means simple. Okay. So when I say random is equal to new random, and I can very well say random dot next int. Now this will give me any random value below 1000. Below 1000, it will give me any random value, and I will concatenate this with, and I'll say value. Okay, I'll say I plus some random value. Okay, so this is what this is. I'm generating some string. I'm generating some string and putting it. How many strings am I putting into an array list? How many strings am I putting in an array list? Come on, friends. Pretty interesting stuff. I think I have already created values out here. Okay, I'll remove this. No problem. I don't need it. How many values? Tell me. How many strings did I put here? How many strings? In the program, you have seen the program, right? How many strings did I put there in the list, in the array list? Come on, I'm waiting for an answer. Take a look. Take a look at this code. So I have, very good, excellent, very nice. So I have an array list. Array list will contain strings. How many strings will it contain? 1000. I would like to show this to you in memory. How does this really look like? See, it's going to be fun. Okay. First of all, I will run this, and after running this, I want to hold on to the program. I don't want this program to terminate, so that I get a chance to take the heap dump. See what am I saying? I'm saying I want to run this program at least to the extent that I get a chance to take the heap dump. Heap dump. Ek aur bar. One more time. Heap dump. I want the dump of the entire Java heap. Come on, we are talking about it since morning. Okay, since not since morning, so but then whatever. We're talking about it since quite a few minutes now. I want the dump of this entire thing. So I'm going to say thread.sleep. Sleep for 10 seconds should be sufficient for me to get the dump. Right, I'll get a chance. So what I'm going to do here is I'm going to run this. I'll go back to my terminal. Okay, it has started. I'll say JPS very quickly. Data types, this is what the process ID is, and I'll say jmap. Acha, thoda time lage. Jmap. Jmap is the command, so I'll say cd pwc training jmap. I will have to run it again, and the command is jmap and the file and stuff. Where is yeah, here it is. The example is right here. Okay, once again I will run this code. So it is running JPS. It's 1587, and here I'll say process ID is 1587. 15872. जब तक खत्म भी हो गया, I'm sorry. So I will increase this. Okay, I'll increase this, so I get sufficient time. Okay, now because the process ID will be different, isn't it, each time? Okay, so it's 15889, 15889, 15889, 15888. Oh no, sorry, it's 15885. Yeah, heap dump. So I've got the file. You can see this heap dump file created. Okay, you can see this heap.bin over here. So this is the dump of Java heap of this program that is currently running. Now I go back to mat. Oopsie, not mail. Oh, sorry, not mail. I'll go to mat. Okay, it's already open. I will say file, and I'll say open heap dump. I could have acquired the heap dump from here itself. This tool is pretty powerful. And then you can see this heap.bin file, which I just created, and see it's analyzing the entire heap dump. And okay, I'll take one of these reports, not a problem. And I will go to, you can see this, don't worry about leaks of specs and all stuff. I will go to dominator tree, and in that dominator tree, you will see in the dominator tree, I have created 1000 objects, and I have created some values out there. You can see this is my main thread. Within the main thread, my dear friends, do you see there is an array list? And it shows you exactly what is the shallow size and the retain size. We will discuss retain size later if time permits. But this is my array list. You can see this, my dear friends, that array list contains what? The object, an array of object. And array of object actually contains 1000 strings, my dear friends. It is showing in 974 more. If I say more, it will it will show more and stuff. But then you can see this here, 1000 strings are here. You can see this. This is a string. This is an object of class string. Within string, friends, please see I've got a byte array. Within the byte array, you can see this. There are bytes here. You can see this value 70 to 28. ये देखो ये उसका value है, my dear friends. You can see this 0th element of that byte array is 86. This, okay, you would be wondering why 86, why not V for value and stuff? Because this is an ASCII value, right? It's ASCII value of it, 86, 97, 100, blah blah blah. Here you go. See, this is right from, you can see this from 0 to 16, and then you can see this is 16. You can see this here, friends. You can see this here. All of these are the values. You can see that here, friends. These are the values. This is the 0th position, and the 1st position, and the 2nd position, and the 3rd position, right up till the 16th position, which is the the default length of it to start with. If it was more than these characters, it will anyways accommodate it, and it will internally extend the size. It doesn't extend the size of an array, it creates a new array and copies the content. Forget about that. But then you see this complete, मैंने आपको dominator tree बता दिया. I have shown you the complete dominator tree here, my dear friends. In this thread refers to the array list refers to the object array refers to each one of those strings which are there, right? These are the elements in that array, and string itself refers to byte array, and that byte array has got values out here, right? And if you go here to value, it will print the exact value 10 403, value 12. You can see this, right? See, all of these are the values. You can see that. You see, it's showing you the actual value to you. You see, and these number, this 330 was dynamically generated. This was dynamically generated with random object, correct? So this is how it is. This is how internally your Java stores object. It refers to, and eventually the value will always be in primitive types. That's how the computer technology is, and it's not only about Java, it's about everything that you work in. So on your memory, like your random access memory, your hard disks, what actually gets stored is zeros and ones, and the primitive types is what your operating system understands. Native data types is what your operating system understands, right? That's how it is. I hope this really helps, and you have got the point across, right? You've got the point that you eventually, finally, the value gets stored in some or the other primitive type only. Otherwise, everything else is what? A wrapper class. And why these wrapper classes? Just imagine they don't give you these wrapper classes. They don't give you the wrapper classes. They don't give you these convenience classes at all. Suppose they don't. Then imagine the amount of code that you will end up writing to execute algorithms in order to execute, simple things that you need. You wanted to reverse a string, you wanted to sort a string, you wanted to do this, you wanted to do that. You have got array list, and then within the array list, all the elements that we've got, you want to find a particular object in an array list, you want to store. I mean, for all of that, you can imagine the amount of code that you will end up writing with all of the primitive types. If you want to store a string in C, if you wanted to represent a name in string in C, you will have to create a char array and then keep on putting the value in each one of those elements and then perform something on string and all. I mean, it's tedious. Hence, higher generation languages, third generation and fourth generation of languages, which gives you data structures, elegant data structures, so that those data structures wrap up the primitive types, and not just simply the data structures, it also gives you algorithms, so that you just simply execute those out of the box algorithms and get most of your work done. Then what remains for you is writing algorithms which are specific to your business application. I repeat, what remains for you is to write the algorithms for your business application, right? They have given you all of these convenience classes. And now my question is, where are these classes? So coming back over here, you've got integer as a class, you've got string as a class. All of these are the classes. Where are these classes? Okay, one would say, yes, java.util array list is in util, java.util package. Yes, package, but kahan hai wo? Where is that class? Where is that class? If you say string is a class, string is a Java, it is in the package java.lang, but where is java.lang? Where is it? And of course, anything that is there in java.lang, you don't need to import it explicitly, it's automatically imported. Where it is? No.
Object class.
No. Good try. I really appreciate your answers. Good try. But no, it's not an object class. Object class is by itself as a class, which is java.lang.object class. See this? It is the mother of all classes. Mother, father, well, whatever. It's the supermost class. You can see this, it's there in java.lang package. Object is a class as good as any other class, and every class that you do not inherit from anything else implicitly gets inherited from object, right? So object is yet another class. So tell me, where are these classes? Kidhar hai? Where is it? Very good, Chandana. Library. Where is that library? Very good. You're very close. How do I address you, Chandana or Lakshmikant? Okay, so where is it, Chandana? Tell me. You're right, library. Okay, you are coming still close, Rakesh. JDK, yes. No, 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 JDK nahi. Because in order to run my program, I don't need JDK. In order to only run my program, I need JRE. Very close, Monisha. JRE के अंदर किधर है? Where is there? Where is it? No, no, no. JVM में नहीं. In JVM, the classes gets loaded. But it's in JRE. Where is it? Where are these classes? Okay, so see this. I will show you all on your machine so that it becomes easier for you, so that you can also see the same thing on your machine. All of you. No, not native, Abhijit. Good try, but good try. This keeps me pepped up that you all are all there and you all are listening to my questions and you all are answering. चलो अभी आप लोग सब एक काम करो. All of you all do one thing. Go to C:/program files/java. All of you all please go there. C:/program files/java. No, not the bin folder. Just go to C:/program files/java. Within that, you will find a folder called JRE. And even I will do that for you, but then I want you all also to do it on your machines. Okay, so you're all there. File Explorer, C:, you must all do this along with me, friends. C:, program files, Java, JDK 11, you are all there. Go to JRE, sorry, go to lib. I'm so sorry. Go to lib. Sorry, go to lib, and in lib you will find. Wait a minute. This is the server JVM. So no. Okay. Vanilla program files. You do not have rt.jar file anywhere on your machine? rt.jar file. src.zip. src will always be there in the SDK, but it will not be there in your it's just the GRE, and I don't need SDK in order to run my application, correct? Okay, maybe I am missing something. See if you can find rt.jar file on your machine. rt.jar file. Yes. See, I have it on my machine. Maybe there is something that we are missing over there and it has not. But it's impossible that rt.jar file is not there. Maybe they have bundled it into some other file which we are unable to catch hold of in the installation that you have on your machine. Yeah, it's a jar file. Yes, correct. No, but then it is not that src zip file. jrt-fs in lib folder. Thank you, Anandya. Let me check that out. So it's so Anandya says we must go to C colon, and she's saying program files. I'm sorry, she, he, I don't know. I'm so sorry about that. And then Java, and then JDK under the lib folder JFR. And no, you said which file? Where is that lib folder? This is, I got it. Okay, JRTFS. No, but then I'm not sure whether this is the one JRTFS. But then we will soon, we will know about it. So what we're going to do is, I'll go back to my desktop. I'll just create a new folder in that desktop. Okay, just for the sake of doing it for a minute, and I copy it over here. Okay, it did not get copied. That's bad. Say copy, and I'll say paste, and I want you to unzip this. No, this is not the one. No, this is not the one. So maybe we are missing something. Okay, no problem, friends. You can still see my screen, right? You can see my screen, right? You can see my screen, friends. Let me show this to you on my machine. See, rt.jar file. rt.jar file is what I have over here. I will go to my terminal, and or rather in the finder itself, I'll say desktop, I'll say new folder, and I'll say demo. And under that demo, I will copy this here, friends. Please see, all with me. Hello. Don't worry about your machine. I'm sorry I could not show you on your Windows machine, but no problem. It is there, definitely it's there. 101% it is there. I am missing a point with this latest version of your Windows and whatever, your Java 11 and stuff and all. I don't know where it is storing it, but then otherwise, you see, I have just copied it on my machine and desktop. You see, I've got demo, and under that demo, can you see this? I have my rt.jar file. I will unzip this rt.jar file for you. RT stands for runtime.jar file, and you see this. After I have unzipped it, there are thousands of classes here, and these are the same classes, my dear friends. It's all done successfully. Unzip has happened. Please see this. I was on my desktop demo, and you can see this under demo. All of this, friends, here you are. This rt.jar file is what I've just exploded. This is rt.jar file which I have just unzipped, and here you go. You see this Java here, friends. Come on, you see this Java. Then can you see this lang out here, friends? And you see this here. Within lang, you have got all of those classes. You've got system class. Here you go, system class. You've got the string class. Here you go, string class. You've got the integer class, friends. Integer. Here you go, integer class. The long class. Here you go, double class. Here you go. You have been working on, I'm sure many of you all might have tried your hands on JDBC. So here you go with Java dot. Where is that? You've got Java dot. You can see this here. You've got lang, you've got IO, applet, and NIO. You see, NIO is what we were talking about, friends. Java.util. You can see this, and then you also have SQL. You've worked with JDBC. Here you are with your connection class. Here you are with your result set class. You see this here. Here you are with your statement class. Everything under the sun that is there in Java, it's all out here. You see IO. Here it is Java.io. Under IO, all of these classes. You've got file reader. You can see file input stream, file writer, file system, file reader. All of these thousands of classes are out here, friends. This is exactly where, this is what your what your Java library is. Now tell me one thing, friends. All of these are what? These are DLL files on Windows. Are these .so shared object library files? Are they, what kind of library is this? What is the language here, friends? What kind of class? What is it? Come on, see this SQL, for example, or Java.util, for example. We just talked about an array list. Array list is a class. You see this here. What are these? This is what? Java. Come on, friends. Class files. I hope you are all there with me. These are all .class files. This is all of this code is written in Java. But then, all of this code is written in Java, no doubt about it. But then, yes, a lot of places, the code that needs to be executed is supposed to be specific to the operating system. It is supposed to be native code. So I will show that to you. See this here. For example, I will go to my object class itself. You see there is a function here called wait. You can see this wait function. This is native function. Can you see this, friends? This is wait, and then from here wait is called, and you see this is native. There is no source code of this function in Java. You will find notify. You see this notify. This is a native function. There is no code over here in Java. There is no source code. I will go to, for that matter, string class, my dear friends, and in string class you see this. I'll take you in the string class. I will take you to intern. See this function. This is native. There is no source code here. It's native. Right? So whenever there is some code that needs to be executed which is specific to the operating system, the Java that you have installed on that machine also has, along with this rt.jar file, note my words, along with this rt.jar file, which is this, your string dot, java.lang.string is coming from that same rt.jar file. Your object java.lang.object class is coming from that same rt.jar file. All of these thousands of classes, I say integer, for example, this integer java.lang.integer is coming from that same rt.jar file. You see this, friends, the connection, right, that you use for establishing connection in java.sql. See this java.sql, here you go. Right, all of these classes are coming from the same rt.jar file, but but good amount of code is still native, and that native code is called from Java here, but actually is implemented in what? So I will again go back to my I will delete this, otherwise it's uploading it to my iCloud. Oh my god, sorry. It was uploading it to my iCloud. Okay, so I have removed it now. So I'll go back to my file, and then I'll go to computer, and then here you have got Macintosh, and then library, and then Java, and then Java. Within Java you've got Java virtual machines, JDK, content, home, and here you will see, my dear friends, in my GRE also there is a lib folder, and there are n number of library files which are Unix executables, which are native to my machine. Whereas if you go to Windows, when you go to Windows, here you will see for yourself that C:, program files, and then you've got Java, and you've got JDK 11, and then here you see in the lib folder itself you do have library files over here. Can you see this JVM.lib, and then you've got lot of files over here, server, okay, quite a few things here, and then bin folder. You see this in this bin folder, these are your .dll folders, friends. These are your .dll files. These are the library files on your machine, these are the library files on my machine, friends. Of course, two different operating systems. Here in case of Windows it's DLL files, dynamic library link file. Here in this case it is dylib file, dynamic library files. It's just that the extension is different. Of course, the architecture and the native operating system and the hardware is different. You got that, friends, right? You got this. यहाँ पे है क्या rt.jar file? ना इधर भी नहीं है. Okay, no problem, perfect. Maybe I'm missing something, there is definitely all of those classes are there. Otherwise, how are you going to get those classes? And then let me close this, and let me close this, and IntelliJ. Well, we will bring that up later. So I hope this answers your question, my dear friends. Where exactly are these classes coming from? These classes are coming from your entire JD, your Java libraries. It's coming from rt.jar file. You got that? It's all coming from rt.jar file. So I hope this is very clear that your Java is actually made up of GRE and JDK. JDK is actually the superset. You get many other tools. Otherwise, it's all about GRE that executes your application. Okay, and then within the GRE, you've got the lib folder. Within the lib folder, you've got the .dll files in case of Windows. You have dy-lib file or whatever the operating system is. You have native files. Some native code is also there, and good amount of code is written in Java, and all that code that is written in Java. Now, yeah, this is the $1,000,000 point that I wanted to come to. All with me? Can I get a quick roll call? Can I get a quick roll call? Good. Thank you. Thank you. Thank you. Great. Superb. Thank you so much. So all of these thousands of classes that they have written in Java. When I say in Java, rt.jar file, the string class, the integer class, the double class, the long class, the connection class, the statement class, the result set class, those thousands of classes, file reader, file writer, all network related classes and stuff, all of these thousands of classes that they have written. If you remove that, if you minus that, Java becomes C. It is as good as C. It's very powerful still, but then you will have to write everything right from the scratch. Of course, you wouldn't want to do that, and that's the reason why you use Java. Why don't you use C? C is more powerful, so to say, but then you use Java because of this Java library, because they have made your life easy, because they have given all of those convenience classes to you, right from the string and integer and long and double to array list and linked list and this and that. Thousands of classes they have given to you so that it makes your life easy. You don't sit and write code for the algorithms and the data structures. They have already provided to you in their Java library. What you need to spend time is writing the business specific code, the code that is needed for your business application, your business logic. Rest you use your Java libraries. I hope this point is clear. All right, and any doubts, any questions, feel free to ask. Right, so we have got these classes. That's how it is. Any doubts, any questions? Any doubts, any questions, friends? So you're clear on this, right? Okay, that's how it works. So coming back here, friends. So what's the time? It's 3:39. What time you all want tea break? What time do you all want tea break? Because post lunch, avoid eating loads of rice during the training program unless you are very much used to it. 4:30 is good, right? Okay, cool, perfect, perfect, very nice. Okay, let's proceed. So this is what I was explaining to you, that the objects are created here in memory, right? This is how the objects are created here in memory, and you have got these references which are there in stack, but you may also have references over here. For example, this value is of type object, it's of type byte array. I repeat, this value is of type byte array. This is not a primitive type. If it was a primitive type, then it would have value right here itself, but this is not a primitive type. So this value refers to this byte array object, hence this is also a reference. This is also very much a reference. So the references may be anywhere in your entire application. The references may be here, or maybe the references are here, and then you refer to the other objects and then other objects, and that in turn may refer to some other objects, and so on. The entire graph is there in memory, and it is that graph exactly that is shown in that memory analyzer tool. That is Eclipse memory analyzer tool. You can download it and use it. It's pretty simple, not a big deal at all. Right, friends? That's how it is. That's how it is. So this is the the typical state of your Java application when you work on it. Why is this important? Why is it important for you to know about this? It is important for you to know about this because you now know what objects really mean. Now you know what are the reference variables. Now you know about the fact that the objects are created in Java Heap. Now you know that one object can refer to the other objects, and so on. right? It becomes your, it makes your life easier, and it makes easier for you to understand what is going on under the hood. Now, very interesting things coming ahead, friends. Please see this. More fun. Okay, please see this. String name 1 is equal to, I'll say Shakir, and I'll say string name 2 is equal to Shakir. First of all, I have a question to you all. These are two different objects or same objects? These are okay, sir. In source.zip java.base language package we have source code files, correct? But that is a source code file, and which is the part of your JDK, right, Rakesh? So do you really need JDK in order to run your application? No. I may not have JDK installed at all. I may just have JRE. So I will not write code there. You write the code, you give your Java application to me, and if I just have JRE, I must be able to use that JRE. That source code that is available is for you to get the source code from your tool, from your IDEs like IntelliJ or like Eclipse and stuff. But that src.zip file is never used runtime. Whereas I need these classes like object classes, and the class like object and string and integer runtime as well. So there must be some of the other file in your JRE, not the JDK, JRE, which contains the entire set of .class files. Note that src.zip also contains that, but then yes, we need the .class files. Correct? Yeah. Maybe what you can do is that later on you download on your personal machines, you download and install just the JRE. I'm sure you're going to find some rg.jar file there. Okay, very good, thank you. Okay, so coming back here, tell me, my question is, how many objects are these? String name 1 is equal to Shakir and string name 2 is equal to Shakir. 2 objects. Okay, Rakesh says 1 object. Okay. Okay, 2 objects, 1 object. Okay, there is 1 single object there. There are not 2 objects. And why? There is a reason. अस्सलाम वालेकुम। आए क्या सेंसर्स आए क्या?
नहीं आए।
अच्छा ठीक है, आएंगे ना तो ज़रा मुझे एक मिस कॉल कर देना, मुझे समझ में आ जाएगा। ठीक है, थैंक यू। I'm sorry about it. Ah, yeah, correct, right. Right, Koneru. Yes, you are right. You're right. Yes, Bhartiya, you're right. JVM will not find any string object if the value is Shakir, so only 1. Yes. Yes. Correct. Superb. Right. Now, for the benefit of all, please see this. Forget about the string pool stuff now. Forget about the string pool stuff. I'll say new string. Now tell me, these are 2 objects, or I'll say new string. How many objects are these? 2 objects or 1 single object? How many objects? Correct, exactly. These are 2 different objects. Though the value is same, the objects are 2 different objects. Okay, so how does this work? No, so let me duplicate this, and I'll say strings. Okay, and here I will remove this. I'll remove this. Okay. Okay, so I have name 1. Okay, maybe that is again just PWC. Okay, and let me remove this as well. I'll remove this. Okay, yeah, and then I duplicate this and I say name1, and then here I say name2. Okay, now the moment I say new string here, the moment I say new string, a new string object is actually created. I'll say new string, and the new string object is actually created. So a new object is created in memory, right? And similarly this also, let me copy this once again. So I'll say name2, though the value is exactly the same, two different string objects are created. Now those who know about string pool constant, they could make a point that okay, only one object was created in the earlier case, but then the others would have maybe some questions. I will come to them, so don't worry about string pool constant and stuff. I'm going to come to it, but as of now just focus on this new string and new string. The moment you say new string, so what happens is that one of these objects is this, for example pwc, and the moment you say new string, name2 is equal to new string, there is again a new object created in memory. Again there is a new object created in memory, and it is this name2 that is pointing to this second object here. That's how it is. Okay, right, this is how it is. And of course you will also have again value out here, right? You will have something like value out here. We'll say value, but then that value will point to what? The string object will point to yet another object here like this, and you see this will point to here like this. This is how it is. And then again this is a byte array. Needless to say, this is also a byte array, and this byte array will have the value P and then W and then C, zeroth element. It's an array, don't forget, it's an array, P and then W and then C. So if I have to compare these two strings, if I have to compare, what am I do? What would I be I'm in a normal circumstances and in a normal way, this is what I would think of. I will say system.out.println, and I will say name1 is equal to name2. So this will return to me a Boolean value, true or false. If it is equal to, it will say true. If it is not equal to, it will say false. So what do you expect to see here, my dear friends? True or false? Tell me, what do you expect to see here? True or false? Tell me, true or false? Take a look. Yes, exactly. Yes. Not that using new it compares references. You're right, Koneru. Perhaps what you're trying to say is that using new it ends up creating two different objects, and using equal to will always, yes, because the addresses are different, Monisha. Perfect. Y'all are bang on. Superb. You are absolutely perfect. When you say equal to name1 equal to name2, what is it that it is going to compare? It's going to compare what? One word answer. It's going to compare what? Memory addresses, and no two memory addresses are same. Impossible. No two memory addresses are same. So when these two memory addresses are compared, of course the answer is going to come as false. It's not going to check the value. So that's how it is. This is not going to, this is going to give you false. See this. This will be false. Correct? This will be false. Now, if this is false, and but the values are actually same, okay, let me change this to PWC. Let me change this also to PWC. The values are actually same, and in your business applications, you don't want to get into this hassle of whether it's a memory address or whatever. So, but then if you know what happens behind the scenes and you know how it works, you will know that this is how you're supposed to check equals name2. So now this will not compare the references. It will not compare the references this and this. No, it will not compare these two references, which is definitely different. It will compare the value in the string variables. So now when I run this, it's going to give me true, because actually PWC is equal to PWC. See, it gives me true, isn't it? Now take a look at this. Integer age 1 is equal to 25. Integer age 2 is also equal to 25. and I say system.out.println age1 is equal to age2. What I'm trying to essentially ask you is whether these two are two different objects or the same objects, age1 and age2. Age1 would be one object, the value of which is 25, age2. So these are two different objects or the same objects. I'm talking about objects, I'm not talking about the value. First of all, tell me these are two different objects or the same object. Okay. Okay, you know what? You are all saying same, and it is just it so happened that I explained. Okay, Likita is saying different. I explained string first, and then I came to this, and then you all are guessing it rightly, intelligently. Rather, you all are guessing it, and you all are guessing it to be same objects, which is right. They are same objects. So if I say equal to, these are same objects. These are same objects. So you see this is also true. So I will comment the string part now, and let me run only the integer part. These are, you're saying true, isn't it? You're saying true. Now the same piece of code, friends, please see, all with me. The same piece of code, I'm simply changing the value. Instead of saying 25, I'm saying 250. Of course, no one lives till the age of 250, but just for the sake of doing it, 250. Now tell me, when I run this, will this be true or false? True or false? No, it's going to be false. Here they go. It's false. What's going on? What's going on? I make it 25. Okay, and I run this. It's true. I change the value to 250. It's false. What's going on? Okay, let me explain. Come on, let me explain this to you. So in order to explain this, see here. Right, so I'll say cd pwc training. Yeah, you remember vi, what was the name of the class? Okay, right, so here you go. Now I've got a blank directory now, and I'll say vi demo.java. Please see this. I'll say public class once again, demo. Okay, and I will say public static void main string arguments. And here, my dear friends, see what I'm going to do. I'm going to write the same code. Integer age1 is equal to 25. And I'll say integer age2 is equal to 25. Same piece of code. I will save this, and I'll say java c demo.java. Okay, compiled successfully. So what did you see here? What did you see here? Integer age is equal to 25. Integer age2 is equal to 25. What do you think is going on behind the scenes? What happens actually is this in the bytecode. Now I would like to show you the bytecode. So I did compile the class, I've got the bytecode. Now I want to see the bytecode. What are those set of instructions that are compiled? Your .java is the source code gets compiled into the Java code, into the bytecode contains the set of instructions. Your Java program then converts that bytecode to, rather compiles that bytecode to machine code and gets it executed, but the set of instructions are already there in the class file, and I want to see those opcode. I want to see the opcode. I repeat, I want to see the operation code. The short form is opcode. So I'll say java p -c and I will say demo, and I get the enter key. This gives me the bytecode in the operation code format, the exact set of instructions that goes to my job, which then is compiled into the machine code and executed. So please check here, my dear friends. You see this, the code starts from here. You can see this, my demo code starts from here. This is my public static void main. You can see this here, and then you can see this byte push 25. This bi push is byte push 25, and then you see invoke static. It actually ends up invoking a function called integer.value of, and it passes that 25 as a parameter. That's how the auto boxing happens. What do you mean by auto boxing? Auto boxing is automatically the primitive type is boxed into an object of a class. I repeat, what is auto boxing? Automatically it boxes, it wraps up, automatically it boxes the primitive into an object. That's what it is. If this, and this was started from Java 1.5 onwards only. Now you see this, I will click right mouse button on my application, and I'll say open module settings, and then I go here to my paths, wait a minute, source code, and here the language level that I'm going to set is kya ho gaya? Oh, you remember I deleted that Java folder. That Java folder was there in PWC training folder. No worries, no problem. हमारा ही कोड था, फिर से लिख ही सकते हैं. It was our own code. We can write it again. So as a new project, that was bad. Okay, so Java training, no problem. I'll say finish. Okay, very quickly see this. So this is the code that we had written, no problem. I mean, we have discussed a lot. So I'll say package. I'll say package, and I'll say com.pwc dot training dot java. Okay, and within that a class, and I'll say demo.class here as well. And you see this here, when I say main function, okay, my main function is here, and I say integer, see this integer, and I say age 1 is equal to 25, and then I say integer age 2 is equal to 25. Okay, whatever is equal to 25. Now friends, what I said is that, what is auto boxing? This is what we were talking about. What is auto boxing? This 25 is an int. This is actually an int. This is not an object. I didn't write new in something, I didn't write new in something, new in the name of some class. I didn't do that at all. Correct? And then I just simply said 25. So this is an int, but what will it do? From 1.5 onwards, it does this automatically. It automatically boxes your primitive type into an object. Automatically it does that for you. And on the left hand side, it is actually a class. So what will it do? It will box that primitive type into an object of that, of course, appropriate type, and assign the reference to this age 1. So age 1 will be a reference to an object that is automatically created by your JVM. Now I'm going to do this. I will click right mouse button and I will go to my open module settings, and then here I'll say instead of 11, I'll say it's 1.4. I'll say 1.4 is the compilation, the language of the level. And you see this, the moment I do that, it gives me an error. It gives me an error. It says requires an integer but provided an int. So what we used to do, what is it that we used to do prior to 1.5? We used to, because auto boxing was not available prior to 1.5, it started from 1.5 onwards. So we used to do something like this, integer dot value of, and then we used to give 25, and then cool, I get an object out here, right? Integer dot value of usage of document of 1.5. Right, enums, keyword, generics, auto boxing, and all that stuff. Yeah, correct. Because still, my JDK is still, I will have to set up entire thing otherwise on 1.4, because here still the level is, the SDK that I'm using is still 11, and that is the reason why it is giving me an error. But otherwise, this would compile successfully in Java 1.4. No worries at all. Right, it's giving me a different error. At least it's not giving me that it is supposed to be an integer. So this is how we used to do it. So now what happens is that this value of, if I say 25, this value of happens automatically. So what I'm going to do, I'll click right mouse button and I say open module settings, and I will go back to my sources, and I'll say that my source is still, it's 11, the latest version. Latest is 16 anyways. So now see, this compiled successfully, integer age 1. So this would have compiled in Java 1.4 also. I repeat, this would have compiled in Java 1.4 also, but this line will not compile in Java 1.4 because auto-boxing was introduced only from 1.5 onwards. So behind the scenes, it is this integer.value of that is getting executed, and that's exactly what I demonstrated to you over here. Please see this byte push 25 and invoke static, the static function. Value of is a static function. You can see that value of is a static function of the integer class. See, value of integer, and this is what it does. This is what it executes. 25 is passed as a parameter. So this is done automatically for you. You don't need to write this line at all. You just need to simply assign a primitive type, and it will automatically box it into an object of a class. So far so good. And now I will take you to the source code of this value of. See this in the source code of value of. Can you see this line? Pretty simple stuff. There is something called integer cache.low and integer cache.high. That means there is some low and there is some high. That means there is some minimum value and some max value. If at all the value that you provide as a parameter to value of function lies between these two values, it will not care to create a new object. Rather, it will pick it up from the cache. But if it is not within the range, it will then create a new object, a new integer here like this. I hope you're getting the point, right? So that is the reason. And what is that low and high? Low is minus 128 and high is plus 127. I repeat, low is minus 128 and high is plus 127. And that is the reason why when I say 25 or any value which is within the range, it actually picks up from the cache, from the integer cache. Take a look once again. Integer is the class, and in that I've got value of. Here you are in. It actually executes this algorithm. Why? Why do you think it is doing this? Why do you think it is doing this? In order to save memory. Every now and then when you say integer, some reference variable is equal to some value which is within the range, and this is the range which is extensively used by millions of programmers throughout the world while writing those thousands of applications, and when they run on the cloud, and when you are running your application, Java has optimized itself. Java provides an optimized version of the runtime environment. It says that these are the values which are very extensively used, not one places, many places in your entire application. Why should I go on creating new objects in memory? Because each time you create a new object in memory, creating an object is expensive in terms of performance. It needs to allocate memory, it needs to set aside some space for it, and then there is an additional overhead of garbage collection. More the number of objects in memory, more time will be taken for garbage collection, which can be hazardous as such. Well, not so much hazardous, at least in this case of integer object. Not that it prevents from some failure or something, but it enhances the efficiency. Instead of churning objects every now and then in memory, at least those integer values which are between minus 128 and plus 127, it will not create a new object, and it will create an object once and for all, of course, and keep it in the cache, and it will pick the value from the cache. But if at all it is beyond this range, then it creates a new object. See this, see for yourself. isn't it? And this is I mean, if you want me to go deeper, integer cache has got a static block, and it is that static block in which it initializes all the values minus 127. You can see this high is 127 and the low is 128, and it automatically picks up those values, and it you can see this range is minus 127 to 127 interned. This is called interning of strings. This is called canonicalizing of objects. I repeat, this is called canonicalizing of objects, creating some standard form of objects and keeping it in memory and reusing it again and again so that you save on creating the objects again and again in memory. There is a concept of instance pooling also. I repeat, there is a concept of instance pooling also. That's a different technique. That's a different trick in the world of programming. But then here, this is the technique of canonicalizing the objects, and that's exactly what it does. And that is the reason, friends, when it is 225 and if you do this s out and you say age 1 is equal to age 2, and you get the value as true. All right, this gives you the value as true. Here you are. But then the moment you make it anything beyond 127, I make it as 128, and this is also 128, it will be false. It will be false. See this? It's false. It's false because it's beyond the range of 127. Correct? So what is advisable, my dear friends? Will you ever, if it's a primitive type, if it is int age 1 is equal to whatever, whatever, and then if you say int, here age, okay, I have already used age 1 and age 2. Okay, v1, and then here I'll say the value of v2 is exactly the same value here. Do you need to worry about it, friends? S out, and I say v1 equal to v2. In fact, you will always use equal to only. There is no way that you use equals. Why? Because equals is a function and an object of class integer, string, and so on. These are not the objects at all. These are primitive types. I do not have the option of dot equals or anything. I do not have. There are no functions. How can there be functions in a primitive type? So I will just simply say v1 equal to v2. Here the comparison is not happening. It cannot happen of references because they are not references at all in the very first place. These are values. So always the comparison will be by value in case of primitive types. When you have objects and references to the objects rather, then in that case equal to will always compare the references. Right, and you really wouldn't want that. Why would you want to compare the references? You may not have. I have never come across a good reason to compare the references unless I'm training and explaining and putting a point across. I will always use equals to check whether the value is equal or not. Now whatever the value is, whatever, it doesn't care to check the references in the very first place. So whether it's the same object, pointing to the same object from the cache, they are the same canonicalized objects, or maybe they are pointing to different objects. I don't need to care about it at all. I just say dot equals, and whatever the value is, whether it's 250 or anything beyond 128 or whatever, I say 240 for example, and I say 240. See this, I'm going to get true here. And needless to say, with this v1 and v1 equal to v2 also, I'm going to get true here. You can see in both the cases it's true. Here it's not comparing by, there is no question out here. It's primitive type. There is no question of references here at all. It's always compared by value. It's always, but here, if it's references and equal, we'll always check for the references. And if it is equal, yes. If it's the same object, it says true. But in my real life application, I'm more concerned with my values rather than the references and stuff. So I rather say equal, and I better use equals. Now with this explanation, I'm sure you've got the good understanding of what the objects are, the references to the objects that gets created in heap, the concept of two different objects, and then comparison of the objects and comparison of the values, and especially the primitive type as well. I will take questions now. Yeah, tell me. Yeah, byte size, that's the max size that they have given. Any doubts, any questions? And just to put a point across, you see I said PWC training, and you see I used Java P, and I said -C. I wrote demo, and this is how your bytecode actually looks like. This is the opcode of the operation code. But if you want to convert your bytecode to operation code and complete class dot to dot, if you want, you can say Java P -verbose. right? And I said demo. Now this will give you the complete ins and outs of the class. So those few lines of code that I had written in my source code actually results into so many things. So in the bytecode I have, from which, what is exactly, the name of the class file in the entire path of it, where exactly it is last modified and how many bytes are there in that class file. This is the checksum. Why is this checksum important? So that you can verify that when it travels over the network, if suppose you give this file to me, or so it stores the checksum inside. If at all I modify the class file directly, I try to manipulate it and do some some circus over there, the md5 checksum will be different if the moment you change the file, and then it can realize that okay, the file has changed. Okay, and compile from which .java file it is mentioned here. What is the minor version and the major version? We are using Java 11. The major version is 55, and these are the flags which are related to runtime constant pool. All of this is runtime constant pool. All of this is the runtime constant pool. This is the constructor, the default constructor. Even if you do not create a constructor, by default the constructor is certainly there, wherein the new object is created and the memory is created. Whenever you see init like this, it's the constructor getting executed. Invoke special is the instruction, which is your machine code instruction, your opcode instruction rather. And then you've got public static void main starting over here. You see the code that we have written and stuff, and then you see this source file demo.java, and that's it. So this is the opcode of the bytecode that we just created. Any questions, any doubts? Yes, string pool. You remember, Rakesh, you all talked about string pool, and you all said that string pool. So you see this again, same in case of string. I say name1 is equal to, I say Shakir. Okay, and then I say string name2 also is equal to Shakir. Now here I'm not using the new keyword. Now what happens here is that it first time it encounters literal. This is literal, right? Shakir is a literal. It's a constant. The value of Shakir will always be Shakir. Million times my application runs through these lines of code. Shakir is going to remain same. So what it does is that if it's a string constant that you have given on the right hand side, it will create a string pool. It's a pool of string objects, and it will store the value of Shakir there in the string pool. And the next time if you try to create a reference variable of type string, if you try to create an object of type string, the reference variable will end up pointing to the same object. It will not create another new string object. Why a new string object, and why a new again byte array, and then put the values over there when the value is still going to remain the same. So name2 will point to, name2 is a reference variable that's going to point to the same string object that is created and kept in the pool. Again, why? So that it saves memory. Similar is the case with long. So long also, if you're using autoboxing in long, here also you do have the concept of value of, you can see this here, value of, and that also works with the long cache. Like you've got integer cache, you've got the long cache as well. So these are the data types. In case of double, it doesn't do that. I don't know, let me check. Value of double, here it is, it doesn't do that. In case of value double, that's what I expected. In case of double, it wouldn't do that, because in case of double it's not practical, right? Because you can have 1, 1.1, 1, 1.2, 1, 1.3, 1.4. It will run into thousands of objects, and maintaining that in memory itself will be again yet another downside of it. So it wouldn't do that for doubles. But long, yes, it does that. Minus 127, minus 128 to 1 plus 127, it does that for the integer as well. Right? I hope that answers your question. Any doubts? Any doubts, any questions? Absolutely feel free to ask. I hope it was not very overwhelming and not I've talked a lot and I did not give you all a chance to write any code. Don't worry, I will give you loads of hands-on. Trust me, I will give you loads of hands-on. But I hope it's okay. We have discussed a lot, but these things are very important, isn't it? Not that I'm blowing my trumpet, but it will be difficult for you to find these things out there anywhere else. You don't need to practice. You don't need to practice. Kaushal, see, let me ask you a question, Kaushal. When you watch a movie, when you go for a movie, 2.5 hours, 3 hours of movie, you take a pen and a paper and you record and you record each and every dialogue? You don't. But then it's there in your mind. So whenever you come across something similar, or when your friend talks about a particular scene, you are able to recollect it. Correct. So similarly, if you have paid attention, right, if you have paid attention in this class, and if you have understood what I have explained to you, even to the tune of 70-80%, when you start working on your real life projects, you will be able to relate to what we have discussed, and that's important. You will be able to recollect and relate. Oh, okay, this is what we had discussed. Oh, acha, ye isliye aisa hota hai. This is how, oh, this is the reason why this is happening. Then in that case, you will be able to relate to it. Correct. See, this industry, the software development field, you all are all freshers, have never worked on any project? No, you don't need to, Anikendu. Byte push, you don't need to. What I was only trying to say is that it internally executes the code in such a way that it caches those objects which are very commonly used. That's exactly a Akinendo, right? The concept of canonicalizing the objects. Byte push, out of 10,000 Java programmers, hardly one would know about it. Anikendu, take it from me. Out of 10,000 Java programmers you pick up, hardly anyone would have even heard of something like byte push. Out of 1,000 Java programmers you pick up, okay, you go back to your, well, that's not a good, I mean, don't be humble and don't be arrogant. Don't go to your, don't go to your colleagues or your seniors or someone and don't offend them at all. That's okay. So I mean, you've got to be very humble. Out of 1,000 programmers, hardly one would know about Java P. They don't even know what is Java P. So that's fine. You don't need to. I am taking you all through those things which is, making you strong, so that, this Java becomes like, simple thing for you. Very simple stuff. And you gain interest in Java. All right. Now I'm going to show you all. Okay, so I hope that. So you all are all freshers, right? You all are all freshers. All freshers, right, correct. So great, super, right. So you all will automatically, when you start relating, when you start writing code, you will be able to relate to this, and you will automatically, this is how humans are. What is the biggest difference? A bit of a tangent, friends, a bit of a tangent, apart from technology. Okay, what is one big difference between humans and all the other living beings? I will be very happy if you give me the right answer. What is that one big difference? They are more intelligent than us. They have got much better analyzing power. A wolf, I and you cannot beat a wolf. Capacity of thinking. While elephants, they can remember things for 50 years, 60 years. That's what I have read. One big feature that God the Almighty has given us, which is very unique and which differentiates us between, no, not even imagination. They can't code. That was nice. No, but there is one big differentiating factor. I repeat, there is one. Socialism. They also socialize here. They also socialize. They have entire, I mean, here in Baroda, in our native place, Khambat, there are so many, we see monkeys. They are always in the social gathering. They are always together. I'll tell you what, I mean, and you all know this, it's just that it doesn't strike. One big differentiating factor, no, not even that, no, listen, think and react, no, not even that. You all are missing the point. And you will love to listen to this. See here, friends. One big differentiating factor between us and all the other living beings. 10,000 years back, Sparrow used to create, the way Sparrow used to create his or her nest, it's the same way Today also the sparrow creates the nest exactly the same way. We have not made buildings. But you see us, where was, no, not even evolution. Where were we and where are we today? 10,000 years back and where are we today? Why? Change, no. What is the big difference? I'll tell you what the difference is. Humans have learned, and rather I would say God the Almighty has given humans the ability to record the information for the next generation. Come on. Yes or no? We have got the power of pen, isn't it? Isn't it? We have got the power of pen. And we write it down for our next generation. Do you think that today the aeroplane that you fly in on day one, that's how the aeroplane was? Isn't it? 50 years back, the Wright brothers or whoever, started with an aeroplane or whatever they started with, that was very different over a period of time. And today, the kind of aeroplane that we are flying in, you know, 50 years back, if you told your dadi, your grandmother, that there will be driverless car, 50 years back also there was a car. But if you told her that there will be a driverless car, she will she'll kick you, right? But today you do have driverless cars, isn't it? How? So and maybe 100 years from now there will be something very different, right? So the ability to preserve the knowledge that we gain, we've got the ability to record that knowledge, write it down somewhere. Now these days somewhere is cloud, that somewhere is actually computers. We write our knowledge over here and then it gets passed on to the offspring. So the ability to understand things, yes, you all are right, you all said analysis and stuff and all, and the ability to relate, yes, and preserve the knowledge. So as you keep on writing your code, you will automatically be able to relate to it, and the more you write your code, the concepts will become all the more clearer and stuff. And then as you proceed further, your skills will keep on getting enhanced. As I said, that was a bit of a tangent, but the fact here is that you will be able to relate to whatever we have discussed during this entire 15 days of training program. Whatever we will discuss, you will be able to relate to it and things. So you don't need to really worry about it. You don't need to really take tensions or how will I remember this, that. It will automatically pop up in your mind when you start writing code. So just flow with the things, and yes, I will give you hands-on. I will certainly make you all do today itself. I will give you a good amount of time to do something. I will give you all some exercises, and when you do that, you will be all the more comfortable. I will certainly, what I'm trying to say is that I will certainly give you all time to do the hands-on on your own machines. Okay, but yes, whatever I discuss, don't worry about it. You don't need to worry about it. You will remember it. No worries. Right, friends? Any other questions? It's almost 4:24. Let's take a tea break here, right? And 15 minutes of tea break. We will resume back at 4:45. Is that okay? 4:45? Yes? Okay. Thank you. Fantastic participation by all friends. Thank you so much. Thanks.